And we are live. Hi guys, sorry I am gone again today. Oh, I'll be here tomorrow for sure, but I got back from Hawaii, yeah, lucky me, and then, boy, all of a sudden, then the district needed me to go to a district office meeting. So forgive me, but I will see you tomorrow. So I'll pass back the tests to tomorrow. We'll talk about them, and we'll get a retake ready for you, but not until tomorrow. So today, what I want to do is go through this with you. Hopefully the substitute has the video up and running. So I went to page 70. I went to page 70 in my journal, and I cut this page out. So if you want to do that, and if you need to pause the video on the computer, you can do that while you guys go to page 70 and cut this out, or at least look at it. And we're going to talk about function notation, or what the heck is function notation. So I'm going to open up my journal and my notebook, and I'm going to go back to what we talked about last week about what a function is. So we talked about the fact that if you have a function, then it's going to be 1x for exactly 1y. And then we've talked about this vertical line test to find out whether or not it would pass the function test. And we talked about how a function is where every x value has exactly one y value. We talked about the domain. Domain's all x values, the range is all y values. Okay. So today we're going to talk about functions again, even more. So I took page 70, and I'm going to leave a little bit of room up on top so I can talk to you about that. And I'm going to tape that in to a journal. Okay. And you can pause the video anytime you need to pause the video. You can pause the video. So I'm just going to tape this in to my journal, to my notebook. This is page 70 out of my my journal. Okay. Here we go. So, function notation. Let's take a look. So, if I look at this f of x thing, the whole f of x, and again, you can pause the video anytime you want, is the same thing as y. So when you see f of x, just think y. But why do we use f of x? Because if I have a line, like this one right here, and I look at this line, that is a function. That line's a function because every x has exactly one y. Or this line right here would always pass a vertical line test. So if it is a function, we say it is. F of x means it's a function. It is a function with x. Now, who cares? Why do we even have this fx? Well, let me give you an example. D of t. This is distance with time. So if you were to get in your car and drive for 4 hours, then the distance you go would be dependent on the time that you drive. That's why we do function notation, because it says more than just y. Okay, but for us, again, anytime you see f of x, just think y. Okay, so let's take a look. So go to my big ideas, page 70, and they've got f of x equals negative x plus 3. Or for us, it's the same thing as y equals negative x plus 3. Same thing. Don't let the f of x bother you too much. Just think y. We'll get more specific about this when we get into Algebra 2 and into pre-calculus. Okay? So, what this means is if we were to look at negative 1, this is an x and a y. So explain how you got each point. So if we have a negative 1 value for x, it's right there. Okay? And then the corresponding y value would be, let's see, it looks at 1, 2, 3, 4. Looks like if I'm at negative 1 for x, look at my graph, then I'm at positive 4. So that would be 4. 0. The 0 for x, f of 0 would be 1, 2, 3, or 3. F of 1, well, if I go to 1 for x, then the f of 1 of the corresponding y value is 1, 2. Looks like it's about 2. And then 2, 1, 2 for the x, looks like the corresponding y value is 1. Okay? So all this is just points again, but in just a weird fancy way, okay? So then standard notation, which is probably the way we're going to use it most of the time. If I take a look at the bottom here, this is my standard notation, this is my function notation. Do you notice the difference? Exactly the same. Exactly the same. But instead of seeing f of x, we see y, or instead of seeing y, we see f of x, because it is a function. Okay, so functions are really a big deal later on. Okay, so go ahead and pause the video. And after you get done pausing the videos, we're going to come back to this and take a look at your notes. So if you can pass out the notes to all the kids, we'll take a look at the notes. Okay, I'm back. So objective. What we want to talk about today is specifically function notation. And today's date is 2/26/2020. Okay, function notation. Okay, so for us, whenever you see f of x, just think y. All right. All right. So let's take a look at this. In examples 1 through 6, evaluate the function. If x equals -4, 0, and 2, we want to evaluate this. So let's plug it in. -4 is an x value. So I'm going to go f of, but instead of, now listen, x is equal to -4. So instead of writing x, write -4, okay? X is equal to -4. So instead of writing x, write -4. So f of -4 is the same thing as equal to, put in -4 for x, a -4 plus 4, okay? So plug -4 in for x for both spots. So f of -4 is equal to a -4 is a +4, so I get an answer of 8. So I'm going to go ahead and put that aside. I can say f of -4 is equal to 8, okay? F of 0, okay, so I plug 0 in. If I plug 0 in, plug 0 right in here, I'm going to go -0, 0 plus 4 is 4. F of 2, so I'm going to say f of 2. Okay, so I plug 2 in. I get a -2 plus 4, -2 for x. -2 plus 4 is 2, okay? Those are the answers I want. Now, when we graph these, we're going to get a line, okay? All right, let's look at number 2, okay? Do number 2 also. Okay, same thing. We're going to go g of -4. So plug -4 in for x, okay? So don't let this confuse you. Since it says x equals -4, plug -4 in for x. So g of -4 is equal to, plug -4 in for x, 5 times -4, okay? So we can say that g of -4 is equal to -20. That's what I'm going to do. Okay, g of 0. Okay, if I plug in 0, right there, okay, plug 0 right in there. See, because x is 0. So 5 times 0 is 0. So g of 0 is 0. G of 2, okay, I'm going to plug 2 right in for x. I'm going to go 5. If I plug 2 as 5 times 2 is 10. Okay. All right. We don't need to do 3 and 4. Well, maybe I'll do, no, I won't do 3 and 4. We'll do those later, okay? Or maybe we won't do them at all, okay? Let's look at number 8, okay? Find the value of x, so the function has the given value, okay? So if it's equal to -20, so instead of writing b of x, we write -20. So right here, instead of writing b of x, it says b of x equals -20. So I'm going to go -20 equals -3x plus 1. This is different. We're not plugging a number in. It doesn't say plug in -20 for x, but we set it equal to 20, so it's totally different. So let's solve, okay? So go -1, -1, I've got a -21 equals a -3x, right? I'm just solving, so I subtract 1, divide by -3, divide by -3, and I get x equals 7. Okay, I'll slow down for a minute, let you catch up, okay? So, it didn't say that x equals these, it just said b of x equals -20, so I set it equal to -20. Okay, let's look at 9, same thing. It says r of x equals 33, so instead of writing, let me get a different color. So instead of writing r of x, let's write 33 right there. Okay, so r of x equals 33. So we're going to go 33 equals 4x minus 3, and I'm going to solve. Okay, so to solve that, we know how to solve for x. We're good at this. Plus 3, I've got a 36 equals a 4x. Divide by 4, divide by 4x equals 9. There you go. Okay. Okay, 12. What are we going to do? Well, we're going to make a table of x values and the corresponding y values. We're going to plug in negative 4, we're going to plug in negative 2, we're going to plug in 0, we're going to plug in 2, and we're going to plug in 4, and we're going to get values here, and then we're going to graph it. So, all right, how does that work? We'll do the first one the long way, and then we can do the rest in our head probably. So we're going to plug in negative 4. So if I go 1/2 times negative 4 minus 2, because I'm going to let x equal negative 4. Okay, so I can do this. Half, okay, so negative 4 in there. Half of negative 4 is negative 2. Negative 2 minus 2 is a negative 4, okay? All right, let's plug in negative 2. So I'm going to go, okay, same thing. I'm going to go 1/2 times negative 2 minus 2. So I'm just taking negative 2 and plug it in for x, that's all. So half of negative 2 is negative 1, minus 2 is negative 3. Put negative 3 there. Okay, if I plug in 0, I'm going to go 0 for x. 1/2 of 0 is 0, minus 2 is minus 2, okay? Now if you have a hard time doing this, you can still use a calculator. Let me show you how the calculator can work for it, okay? So if I want to plug in 2, so let's say you have a hard time with fractions, okay? So one way you can do it is go 1/2 and plug in, see I'm putting it in, plug in the 2, subtract 2, okay? So I just took in my calculator, plug the 2 in for x, so I've got it right there, enter, I get negative 1. I think you see a pattern, hopefully you see a pattern. Same thing, I plug in the 4 for x. If you have a hard time with fractions, 1/2. You plug in 4, and then subtract 2, I get an answer of 0. Okay, so these are points. Well, let's graph these points. Okay, so negative 4 for the x, so I'm going to graph these. Negative 4 for x has a corresponding value of negative 4. Okay, there's a dot. Okay, I'm going to put that dot right there. Negative 2 has an x value of negative 3. Okay, so I go back negative 2, down negative 3. 0 has an x value of negative 0, has an x value or a y value of negative 2. 2, if I go over to 2, I have a y value of negative 1, and then 4 and 0, and it makes a line, a straight line. So we're going to call that a linear. So I'm going to connect the dots, and there's my line. Okay, I want to do one more. I do want to do 13, okay? I do want to do 13. I want to make sure you guys get this down. So same thing. If I create a t-table value, I'm going to fill in this chart, call that a t-table. I'm going to use this chart. I'm going to take negative 2 and plug it in for x. Okay, so I'm going to go, okay, I'm going to go t of negative 2, because I'm going to plug negative 2 in for x, is negative 2 times negative 2 plus 1, okay? Negative 2 times negative 2 is 4, plus 1 is 5, so I get a value of 5, okay? So then I'll plug in negative 1, so I'm going to plug negative 1 in for x. So the same thing, I'll go t of negative 1 is equal to negative 2 times the negative 1 plus 1. So I'm just going to plug in my negative 1 in for x, okay? That gives me a positive 2 plus 1 is 3. If I plug in 0, I'm going to get t of 0 equals a negative 2 times 0 plus 1. So I'm just plugging in 0. That gives me a 1. Do you see a pattern? Hopefully you do see a pattern. If I plug in 1, I get negative 2 plus 1 is a negative 1, but you hopefully see a pattern. I plug in 2, negative 2 times 2 is negative 4, plus 1 is a negative 3. Okay, so you do, hopefully you see a pattern. Or if you, again, I can show you on the calculator if you don't know, if you have a hard time plugging things in. I can go negative 2 parentheses, and if I plug in my 1 plus 1, I get an answer of negative 1. Okay, so these are points. These are points on my graph. So I'm going to go, first of all, these are points I'm going to put in my graph. So x is negative 2, y is 5. 1, 2, 3, 4, 5. These are points. If x is negative 1, my y is 3. 1, 2, 3. Remember, f of x and y are the same thing. If x is 0, my y is 1. Hopefully you guys can see we've got a straight line. When x is 1, y is negative 1. And then when x is 2, y is negative 3. And I just connect the points. Okay? And again, you can pause the video anytime you guys need to if I get going too fast. All right? This is kind of complicated, and we'll talk about it again tomorrow, but I want you to do your best to take good notes today. Okay? Ready to turn the page? All right. All right. Now, 14. All right. It's not that hard. Let's think about it. A senior class wishes to put on a dance. Tickets cost $25, and the rent for the gym is $200. Okay? So if they're going to make some money, some income, I of n. So I of n. Let's think about that. That's income. That's income with respect to the number of tickets. I'm going to write that. That's income with number of tickets. Okay, instead of y, instead of f of x, it's I of n because we're making income with the number of tickets. Okay, so if we're going to make money, we've got to sell tickets. So I'm going to say it's equal to 25n because every time I sell a ticket, I make some money. If I sell one ticket, it's $25. I sell two tickets. But we're already $200 in the hole. We've got to rent the gym. So if we don't sell any tickets, we've lost $200. So we're going to say minus $200 because that is minus income. We had to rent the gym. We're already behind. Okay. Now, what's the domain range? Okay, the domain range is n equals, you ready? 0, 1, 2, 3, ... Okay? Because we're going to sell either 0 tickets, sell 1 ticket, sell 2 tickets, we sell 3 tickets, 4, 5, 6, 7, 8. We can't sell half a ticket. We can't sell a third of a ticket. That's why I've got the 0, 1, 2, 3. Okay? The range. Okay, that's my domain. Domain and range is going to be this. We're going to make either negative $200 because if I sell 0 tickets, sell 0 tickets, I've made no money, but I still owe $200. Okay. If I sell 1 ticket, I'm going to be 1 ticket is $25 minus my $200 makes negative $175. Okay, let me explain that. If I sell 1 ticket, I make $25, but I'm already $200 below. Okay. If I sell 2 tickets, I've made $50, but I already am behind with $200, so that's negative $150. Okay. If I sell 3 tickets, okay, if I sell 3 tickets, I make $75. Let's check it out. If I go 25 times 3 tickets, but minus my $200, I've got negative $125. I've got to sell a few tickets before I break even. Okay. So negative 125. So these are my range. Okay, this is my number of tickets. That's my my income. Okay, using a T-table, graph the income. So I'm going to get a piece of paper out here. Need a piece of graph paper to do my graph. Let's see what I got. Okay, so I don't know if you guys have to get your journals, but I'm going to get some graph paper. If you need to pause the video while kids take out their graph paper, you can. So I'm just going to keep going. If you guys need to pause it, you can. So number of tickets down here. Number of tickets. Okay, so I've got 1, 2, 3, 4, 5. Income. Okay, well, I better make my graph a little bit more negative because it looks to me like I can have negative income. So, negative 200. So if I go by 25s, negative 25, negative 50, negative 75, negative 100. And again, anytime you want to pause the video, and I can slow down for a second, I'm just going to put in my scales. And if you guys want to watch, that's okay also. So negative 200, way down here. So here's how my graph looks like. If I sell no tickets, so taking these values here. I'm going to take these values here, and I'm going to put them on my graph, okay? So if I sell 0 tickets, I'm negative $200 in the hole, okay? If I sell 1 ticket, I'm at negative 175. If I sell 2 tickets, I'm at negative 150, and I keep gaining and gaining and gaining until eventually when I sell 5, 6, 7, 5, 6, 7, 8 tickets. When I sell 8 tickets, I break even. Break even means, okay, all right, woohoo, you know, I don't owe any more money, okay? So there's my graph, and it keeps going. Hopefully I'll sell more than 8 tickets because I want to make some money, right? Okay, there's my graph. And I do not connect the dots because that would mean I'd have to sell half a ticket. Okay, don't connect the dots, okay? Now, what is the income if 100 tickets are sold? Well, let's use my equation. I had an equation of I of n equals 25n minus 200. Okay, so that's no problem. I'm going to plug in my 100 for n. For 100 tickets, I'll plug 25 right there. There's my equation. I of n, income to the number of tickets. If I win 100 tickets, I'm going to plug in $25 per ticket. So I'll do that. I'll go I of 100, which means the income for 100 tickets is equal to 25 times 100 minus 200. I use my calculator. I can do it very easily. Or I can just use my brain. I can 25 times 100 minus my 200. And I'm going to make some money. Woohoo! We made, all right, senior class just made $2,300, okay? Might help them on their senior trip, okay? How many tickets must they sell to break even? Well, we saw that on our graph. We saw that on our graph. It turns out to be 8 tickets, but we can also do this with a little bit of algebra. So if we set it equal to 0, okay, and we solve. So we're going to say, what if the income is 0? That's break even. How many tickets do we have to sell? So I said, okay, well, instead of I of n, let's say that income 0, that's break even. Let's solve, okay? Plus 200, plus 200. I get 200 equals 25n, right? Divide by 25. Divide by 25. And what's 200 divided by 25? And sure enough, I get 8. And I saw that in 2 ways. So that's 8 tickets. And I saw that in 2 ways. One, we set the income equal to 0. That's break even. And we solved the equation. We got n equals 8, which is 8 tickets. Or you can see on our graph right here, our income is 0, and that's our break even at 8 tickets. Okay, you have homework to do and an exit ticket, so I will see you for sure tomorrow. So sorry I'm not here, but I'll be here tomorrow, and I'll be here tomorrow at Flex.